Hi, I'm Carl. In this video we're going to be going over the final two units of section 3 of the blue booklet, so that's going to be unit 20 and unit 21, or questions 53 to 56. 53 to 55 talk about the enzyme alcohol dehydrogenase, and we're given a bit of information here. I'm just going to summarize it quickly. It says that if you have a carbon atom with an oxygen or a hydroxyl group on it, ADH will react to it if there is another hydrogen here, and then that will produce this carbonyl group instead, like this. So this hydrogen is necessary, and then this hydrogen is also taken off. 53 says the reaction of an alcohol with ADH is an example of what? Well, if we're taking away hydrogens, that's going to be an oxidation reaction. So that gives us an answer of A for that. 54 then says the reaction of 2-butanol with ADH would produce what? So I think the easiest way of doing this is just to draw it out. 2-butanol would look like this, and it would be converted into this, obviously with the hydrogens as well. But that gives us a ketone with 4 carbon atoms called butanone. So that gives us an answer for this one of B. If we look at 55 then, it says which one of the following statements about ADH with alcohols is not correct? Okay, so let's just go through them all. A says the product formed by the reaction of a primary alcohol with ADH is an aldehyde. So a primary alcohol, of course, is going to be, I'm just going to draw out some more carbons here. It's going to be an alcohol with the OH group on the terminal carbon. In other words, a more formal definition would be that the carbon that the OH group is attached to is only attached to one other carbon atom, and it's not in the middle of a chain. And so if we did react that with ADH, and actually I'll just draw it on here, we'd see that the hydrogen would be removed and we'd get this carbonyl group here. And a carbonyl on a terminal carbon in a chain is going to be an aldehyde, so that is correct, and so not the answer in this case. B says the product formed by reaction of a secondary alcohol with ADH is a ketone. Well, if we take this back and just make this a secondary alcohol, which means that there's 2 carbon atoms on either side of the carbon with an OH group on it, would that be a ketone? Well, if we got rid of the hydrogen like ADH would and drew in our extra bond with this, we would form indeed a ketone, just like in the example above. So it's going to be, that is true, and so is not the right answer in this case. So if we look at C then, the product from a reaction of a tertiary alcohol with ADH can either be an aldehyde or a ketone. So we talked a little bit about the requirements of ADH in order to work, and it needs a hydrogen atom up here to take, for this oxidation to take place. But if ADH is trying to attack here, then it's not really going to work because it doesn't have an extra hydrogen, obviously, to work on. So tertiary alcohols don't actually react with ADH. So you're not going, so that one's definitely not correct. And so that is the answer for this one. So the answer is going to be C. But to rule out D, it says a tertiary alcohol does not react with ADH, which already worked out is true. So is not the answer in this case. So the answer for this one is going to be C. I've got the final question on the paper here, which is question 56, and it says that water undergoes self-ionization according to the equation that's given here. And we're given also the equilibrium constant at 2 different temperatures. Now I've drawn out the one at 60 degrees C and an equation to determine this. It says at 60 degrees C, pure water has a pH value that is what? And it says something that's a little bit strange here about how water could be acidic or basic or neutral. So I'm just going to talk a little bit about what happens when water dissociates. So you end up with this hydrogen and hydroxide group that are produced. Obviously this is going to be acidic and this is going to be basic. For every one that you produce, so say for every hydrogen ion you produce, you also produce an OH ion, and they cancel each other out and make sure that everything is neutral overall. You're not going to have an excess of hydrogen ions at any point, so it could never be acidic. And you're never going to have an excess of hydroxide ions, so it can never be basic. So I know it sounds a little bit obvious, but water is obviously always going to be neutral. So that rules out 2 of these different answers then, and it says what the actual pH would be. So I think the easiest way to do this is probably just to work it out. So the equilibrium constant, and you can see that in a couple of different forms, is going to be the concentration of the dissociated forms divided by the concentration of the undissociated form. But what's the concentration of water? it's going to be 1, because even though water does dissociate slightly, it's very, very, very slight. And so the concentration of water basically doesn't change between its dissociated and undissociated state. And so we can just roll this out and say the concentration of water doesn't change, and this expression for the equilibrium constant is going to be just the product of the hydrogen ion concentration and the hydroxide ion concentration. To make this even easier, we don't know the hydroxide ion concentration, but it's going to be the same as a hydrogen ion concentration because we have this 1-to-1 ratio. For every one of these you have one of the other, which means that the Kc, and there's a couple of different terms you can use here, is going to be this squared. So if we know that 1 times 10 to the minus 13 is going to be the concentration of the hydrogen ion squared, we can then divide the indices essentially by 2, and we get 1 times 10 to the minus 6.5 as the concentration of the hydrogen ions. If we plug that into our equation for pH, which is going to be minus log root 10 of the hydrogen ion concentration, that gives us a pH of 6.5, which is less than 7, and so that tells us the answer in this case is going to be A. So that was the final 2 units on the paper, Unit 20 and Unit 21. I hope that helped. Thanks for watching.